Good afternoon to you all, and welcome to this Mobile Ecosystem Forum webinar in association with Juniper Research. Today we're going to be looking at low power IoT, the market outlook and future opportunities, and Juniper will be taking us through there. Andrew Parkin-White, I'm the MEF advisor on mobile IoT, which is one of MEF's 6 work programs. For those of you that don't know, MEF is a global trade body that promotes industry opportunities and champions issues affecting the mobile ecosystem and represents its stakeholders. MEF operates through working groups, knowledge sharing, and ecosystem interaction. And please do contact us for more information on how to become part of the ongoing discussion. Today's webinar is going to be running for about 45 minutes. And you'll be able to share with colleagues through the email sent after this session. There will be a blog and links to follow after the webinar. Importantly, there's a button at the bottom of your screen for Q&As. So if you want to submit any questions to put to Juniper, please do so via these means. Please do ask questions throughout. We appreciate your interaction. So the IoT market is set for explosive growth, and today we're going to be looking at a number of issues around low power IoT technology, how they'll be developing over the next 5 years, how they'll complement existing IoT networks, what strategies stakeholders can implement to capitalize on growth of low IoT networks. We're looking at the value of the market in the next 5 years and the role operators have to play in the future low power IoT market. So I'm now going to hand over to Elson Sutanto, who's the principal analyst at Juniper, and I'll let him introduce himself and Juniper, and then we'll move forward with the presentation.
Thanks very much, Andrew. And yes, today I'd like to start by saying that we will, as Andrew was explaining just now, the IoT market, looking at outlook and future opportunities really within this sector. So before I move on to the agenda, I just want to explain that Juniper Research has been around since 2002. We conduct research, analysis, forecasts, data sizing, market sizing into the digital technology and telecoms arena. We serve a range of different IoT ecosystem stakeholders such as OEMs, mobile operators. So please do get in touch if you have any queries about any potential work or areas that, within the digital technology space that you'd like to know more on, and we'd be happy to help you there. So without further ado, I'd like to move to slide 2 of the presentation, which says agenda. Just to explain to you guys what we will explore today. As you can see here, we'd like to really give you first a look at the future of IoT and its key takeaways. We'll then explore alternative IoT technologies that are in the marketplace. We'll then look at challenges for eSIM technologies and what is really holding or potentially holding them back. Number 4 is we'll look at some key predictions or some key kind of forecasts that we see unfolding for the next few years. We'll look at and explore the future of eSIMs, the deployments and launches of cellular low-power networks worldwide by geography and market. And again, we'll look at certain verticals that LP IoT is really, really suited for, including agriculture, POS and banking, smart cities, smart metering, and smart grids. And finally, we'll give our kind of key thoughts on some strategic recommendations for you to digest. So if we can move to the next slide, the future of the IoT and key takeaways. Here really, we want to summarize just a few key things about LP IoT or LPWA, as you would say. Firstly, let's define what we think Juniper Research sees LP IoT as, and that is the connections, interfaces, and infrastructure that allows small packets of data to be transferred from remote sensors, and these sensors can be leveraging LPWA networks to monitor remote stationary devices and sensors. And so the key takeaways, the key 4 takeaways that we have here is the fact that there is a no one size fits all approach. So there's no one LP IoT network that will solve everything in every vertical and every application. What we do see really here is that LP LPWA or LP IoT connectivity has increased the value proposition of other wider technologies. It will become vital, and it is playing a vital part in increasing IoT networks' capabilities to integrate with other IoT technologies. And given that on top, each vertical industry should be considered separately, requiring different combinations of wireless technologies, including LPWA technologies and different management tools as well. What is interesting as well from our research that we can or have deduced is that smart cities, smart metering and commercial building energy management solutions really see strong adoption or strong uptake of LPWA technologies over the next 5 years. So the characteristics really of LPWA being having to operate over a long battery life as well, with wide coverage, with transmitting small amounts of data, is really, really fit for these kind of verticals as well. We've also had much talk really, and we've seen developments over the last few years with eSIMs really, with GSMA pushing out the standard there and the specification there, working a lot with other IoT ecosystem players, such as operators and vendors and OEMs to really, really bring that to advance, coming to the forefront as well. And here, as we were saying earlier, low power connectivity will be part of the wider IoT rather than just be a single competing technology. So if we can move as well to slide 4, please, that would be great. Right, so what we see here is we've just pulled out really a few kind of key takeaways that we'd like you to know really and to digest. And that is for the total market, I think, of IoT connected units. We see that coming around to be the 64 billion or over 60 billion figure by 2023. Of that amount, over 1.3 billion will be cellular M2M connections as well. And really where we see cellular low power M2M connections by 2023, we think that that will be really in excess of 100 million connected units really. So that's where we really see those kind of figures coming in. As well as that, to the right of the graph, you can see here that total M2M connections, we believe right now are around about the 600 million mark really. And we believe that we'll see moderate growth into 2020 next year to be between 700 and 800 million M2M connections. So if we can move on to the next slide, that would be great. Great. So what we see here now with the next slide is a bit more focus on eSIM technologies really, and the market challenge there for eSIMs. Well, what are eSIMs? Really, these are SIMs that are embedded into the device, soldered in really, so there is no need for kind of a physical use of an actual SIM card. And as mentioned earlier, this has been standardized by the GSMA as well. It allows updates and the changing of operator profiles over the air with remote SIM provisioning as well. And in a way, it is helping to reduce the complexity and the cost of deployment, and allows connectivity providers to reduce really their costs and pass this on to the user. Now, it's really, as mentioned earlier, there are a few verticals which we will explore later in this presentation that eSIMs are really, really relevant to really. We have seen here lots of work done in the last few years with the automotive segment as well, and the telematics segment being one of the earliest adopters really of eSIMs, and that is helping really to kind of spill over into other kind of verticals and regions that can learn from the automotive and telematics launch of eSIM really from years earlier. So what we know really is that eSIM is really helping to produce a few advantages here, and that's really simplify the kind of cost as well, the activation of the actual SIM over the air as well. And as well as that, we see strong verticals such as smart cities, smart metering holding next kind of strong potentials for adoptions of eSIMs really. And as well as that, what we see here is that by 2024, we believe that over 70% of vehicles with cellular-based telematic services will be having an eSIM in use. So that is quite a high percentage and figure really. As you can see here as well on the slide to the right, we are looking here at the proportion of M2M SIMs that are embedded SIMs really over the 29 to 2024 period. We can practically see that by 2024, smart cities will be having a lot of deployed or majorly deployed, almost to 100% of eSIMs within a range of different applications. And this is because a lot of the devices operating in smart cities are in hard to reach locations, making size and reduced kind of cost and of deployment and scalability really fitting with eSIMs as well. Smart metering again is again, as mentioned earlier, a very strong and suitable application for eSIMs as well, helping to reduce, for example, things like the cost of sending out someone to read the meters, and has a very strong use case to use cellular technology to transmit that data from meters to the actual energy company or supplier. So if we can move on to slide 6, that would be great. So key predictions we see really for eSIMs over the next years, as we were saying, is that smart cities, although it is relatively a new concept compared to automotive or healthcare, we'll see strong adoption of the actual eSIM technology over the next few years. And this really is because as the eSIM was becoming specified and standardized by the GSMA and by other IoT ecosystem players, many smart city devices have been released after those standards were really established. So really what we anticipate is that many smart city devices will operate over LPWA technologies, and where sensors will create a really suitable environment for increasing usage of eSIMs. So yes, if we can move on to the next slide, that would be great. So here what we're seeing really is, or exploring really, is the future of eSIMs. And what we anticipate is that eSIM technology is expected to increase around or across a range of different sectors. And we are really forecasting very strong, significant growth in excess of 300% over the next 5 years. You can see here on the right on the graph that we are really expecting the proportion of M2M SIMs really to be around 220 million in 2019, going up to around 320 by 2020. So what we also see is that each sector is facing different challenges to adoption. We're seeing different stakeholders, including operators and service and device vendors and end service providers themselves, have different levels of motivation to deploy eSIMs. So for example, for mobile operators, using eSIMs really simplifies SIM distribution. There is no physical SIM card distribution. And this in turn makes it very much easy to manage without physical SIM card distribution, having just one, I guess, single stock keeping unit really for those connected devices in which the eSIMs will be placed in regardless of location. And this gives rise to deployment of new global IoT businesses. In M2M as well, what we see usually before the eSIM with the physical SIM is that usually it's relying on an alternative type of technology such as Wi-Fi or Bluetooth to be bootstrapped and to be active really through those alternative technologies. But with eSIMs, the device can actually be activated there and then at the point of manufacture. And some would say that this is really a natural evolution really of where operator business models are going with eSIMs. For OEMs, really what we're seeing is the simplification of supply chains, shortened production time and the time to market as well as that with OEMs gain very good visibility of the actual device in which the eSIM is in at the point of manufacturer. So they can access that data, they can gain sight of that device and see its activity right away from where it's manufactured as well. So for service providers, what we see is that MNOs, there's a choice of MNOs that service providers can offer really to their customers really, and they can give them the choice of different profiles of operator networks depending or determined really by network coverage and signal strength. You can also, for example, go to a provider with one contract with pre-negotiated charges to different networks as well. And the service provider also has the opportunity to act really as a one-stop shop for add-on services really. And overall, really for the industry, what we're seeing is that there's a reduction in size with eSIMs, so there's cost and space savings. There's flexibility of switching MNO networks as well. And again, no need to design, stock, or track different SIMs, really. So that's really the overall benefits or advantages of using eSIMs. However, we do see that some stakeholders may wish to avoid eSIM implementation because of the ease of switching connectivity provider, as mentioned earlier. Some vendors might also be unlikely to gain much benefit from the standards and will be willing to adopt the technology unless the existing standards change. So what here we're saying is that many of these vendors will really have to take into account the changes that the standards will have established within eSIMs when they are incorporating and manufacturing their models, really. But going forward, what we see as Juniper Research is that many of these embedded SIM modules will be certified, deployed over networks as well, and more kind of players will come to the forefront in the ecosystem. And again, that will really help to increase price competition. If we can move on to slide 8, that would be great. So here's just a nice visual graph, really, of the different deployments of the different low-powered technologies worldwide, really. And really what we're seeing here is that the different deployments are kind of reflecting different, let's say, strategies of different operators and what strategies and which verticals they are actually deploying in, really. So, for example, you know, we as mentioned earlier, we've seen strong traction of eSIMs within the automotive and telematics segment, particularly in North America and parts of Europe as well, and Latin America. As well as that, we said that there would be a plethora or range of different low-powered wide area technologies, both licensed and licensed, coming to the forefront and really operating, you know, worldwide, really. So here you can see in some markets that there is a deployment of LTE-M and NB-IoT as well, where they are actually in the same markets. As well as that, for in terms of technology rollouts, what we have researched is that really there's around 100 operators in over 50 countries launching either NB-IoT or LTE-M. As well as that, 22 countries have, I think, deployed or launched NB-IoT or LTE-M networks, and 28 countries alone have deployed NB-IoT networks only. So there's just some interesting stats for you as well to hear. If we can move on to slide 9, that would be great. Thank you. So here is another sector that we see very strong application for LPWA to be launched in, really. And that's really agriculture. And why is this? Well, developing regions are dependent, let's say, on grown crops, and food shortages have the potential to be alleviated through the introduction of sensors and crop livestock management platforms leveraging LPWA that can kind of reduce wastage. As well as that, there's strong use cases for LPWA sensors to monitor a range of KPIs within agriculture. It could be soil moisture, temperature, wind kind of speed as well, and resistance, for example. And we believe that the business models offered this time by unlicensed LPWA technologies will be an attractive option for agricultural users. And we see that two aspects of these services will appeal to users. Number one is that the unlicensed LPWA technologies will have low investment costs, in some cases lower than licensed LPWA options, and they have future network scalability. So players or organizations such as for example, the LoRa Alliance have had a very good head start over the years or previously in launching some of their networks in a range of different markets and regions worldwide. For the developing regions, we see farming institutions in regions like the Indian subcontinent and Africa and the Middle East unlikely to perhaps gain or gain sufficient budget to be able to invest in IoT solution in the next 5 years, despite forecasted price falls and the increasing threat of SIM theft and device tampering that these markets and the farming industry does experience here in these particular developing markets and regions. Additionally, we also see continuing need for subsistence farming in these regions, which allows little monetization opportunity for IoT services providers. So that's our summary for agriculture. If we can move on to slide 10, that would be great. So here we are looking now at the POS and banking sector and the applicability of LPWA to this sector. Well, we really anticipate that POS, retail and banking is one of the sectors that will gravitate specifically to NB-IoT over LTE-M, due really to the small size of data packets that the industry historically has used through GSM networks. We believe the heaviest users of POS devices will also be across North America and Western Europe, with all regions except the Far East and China anticipated to have stable kind of average usage per POS devices over the next few years, really. And what we were seeing here is that often MPOS devices being adopted by SMEs have been often connected to another device via Bluetooth or Wi-Fi tethering. And in turn, this negates the need, or has in the past negated the need, for a dedicated low power connection through cellular or unlicensed spectrum. We believe, though, that because vendors are increasingly having included 4G connectivity in POS devices, this creates a strong or a good foundation, really, to drive the ability to offer cellular LPWA connectivity. And as you can see here, by 2024, we believe that there will be over 2 million unlicensed LPWA connections in services for POS and banking use cases, growing from less than 200,000 connections in 2019. As the established POS ecosystem has in many instances come to rely on connectivity, it will continue, we see, it will proliferate and continue to use devices with cellular connectivity modules included in the point of manufacture. So if we can move on to slide 11, that would be great. So here we're going now a bit more into the smart cities arena, as we were exploring, or as I was explaining earlier, really. And really what we're saying here is that existing communications infrastructure in many smart cities does have varying requirements of device communications. And as we deduced earlier, it does result in many different multiple technologies, or the necessary need for multiple different technologies to be deployed across its footprint, really. Again, because many of these devices are small, they're in hard to reach locations, they need good indoor coverage, for example. We see LPWA as a really, really fitting technology, really, to serve smart city applications. Here we see in the second point that power and cost constraints really have in the past resulted in majority of new devices deployed using wireless communications, namely really unlicensed LPWA technologies, Zigbee, or even personal area network technologies such as Bluetooth. We forecast that really over half of smart city IoT connections will use LPWA technologies. The low cost of connectivity will attract smart city platform users who are motivated by cost savings and securing return on their investment in a smart city platform. And of course, LPWA, and as we mentioned earlier, potentially with eSIM developments, scalability really across the city to be able to collate all this data, standardize it really, and for further analysis is going to be very key. And LPWA will play a very, very strong key part really in providing that coverage, reducing that cost as well, really. There are really, I think, to add to this, three kind of constraints that the city must be aware of, really. Poor urban mobility, for example, is going to lower business competitiveness, and also financing of these particular LPWA projects, for example, or any smart city project is quite a challenge really for authorities, for national policies, for governments as well. And then, of course, deducing the use of different technologies, including the different strands or flavors of LPWA, will be very, very important to deduce. So if we can also now move on to the next slide, that would be great. So here is just really some further thoughts on smart metering and smart grids, where we see also another strong opportunity for LPWA to come into play, really. As you saw, I think, from the previous graph, there is a very, very, very strong use case really for LPWA to provide the connectivity in a lot of these smart metering rollouts, really. So the commercialization of the smart grid is going to have a significant impact on the manner in which energy is sold. One of the key reasons is that energy, one of the key reasons behind this is that the generation of energy is far more distributed than is presently the case due to the build out of renewable energy resources. Secondly, also, we see smart metering rollouts funded by utility and billing companies, but really the drivers coming from governments and service providers themselves that are driving developments in this area, and now having a strong idea and strong understanding of the potential for LPWA really to help with these smart meter rollouts really, and to aid in terms of reducing cost, gaining scale and increasing efficiency really with the rollout of LPWA over or LPWA devices over long periods of time to operate on low power and with small battery life, for example, and to transmit small amounts of data. So here, you know, with governments understanding it, national providers as well, billing company, energy companies as well, really what we're seeing is that we're seeing really an opportunity to save on meter reading costs as well, and governments to benefit from more efficient utility networks. And in this regard, what we see is LPWA technologies are suiting that industry need as well. As mentioned earlier, offering a low cost per connection enabled by a low data traffic and duty cycle. Both NB-IoT and LTE-M will leverage LTE, so previous rollouts of LTE or 4G, which can customize those settings for via virtualization of the networks really. So here we also I just thought I'd pull out a few couple of interesting points really. So while the EU plans to achieve a minimum penetration of 80% of smart meters per country or member country by 2020, we forecast that smart meter penetration in West Europe will be around over 50% by 2020 by that time. China as well has had its government really pushing quite a few smart metering related advancements really in this arena, and it has invested quite strongly from its national energy provider in smart grid energy growth with over 69 million smart meters tendered by 2 utilities alone in 2016. And given those developments, we believe as Juniper Research that over 70% of households will have smart meters installed across the country in 2023. And I think that brings me to the end of the presentation. My apologies that it was all quite summed up, but I hope I hit some nuggets and gave you food for thought. So over to you, Andrew. It's great.
Thank you very much, Elson, for that very informative and comprehensive presentation. We do have a couple of questions that have come in, so in no particular order, I'll put you on the spot. So how do you see cellular and unlicensed options for low power technologies competing against each other over the next 5 years?
Good question. I think that is at the forefront of a lot of different people's minds really within this space really. I think pricing is an area of competition for both solutions really. You know, pricing really must consider really the pricing of LPWA solutions for the license providers has to take into account the effective unlicensed solutions that are really coming to play. Otherwise, those licensed players will risk losing potential new clients to these technologies really. And this applies to kind of operators as well, in which they charge the monthly connectivity and enablement fee, as well as the device vendors as well, which can affect the initial investment, let's say, and cost in IoT devices really. So I think the average price of both connectivity and devices has decreased over the past 24 months. But the question is whether licensed pricing can get to the levels, or the low cost levels of unlicensed LPWA connections. So so Juniper Research is really urging strategically for cellular LPWA providers to ensure that they can promote the superior capabilities of their platforms to their competitors. So that is really a key area that we can see. I also think in some markets or regions where you're seeing both deployments of NB-IoT and LTE-M, that obviously offers much more choice for different verticals depending on the use case as well. But it also depends, I think, on the agreements between the different IoT ecosystem providers and how commercialized that can make it. So the different options, the different verticals as well, in addition to the pricing I was mentioned, these are all areas that will be kind of the foundation or the ground on which to compete upon.
Thank you very much. Interestingly, operators are going to be interested by this market, mobile network operators, that is. But they seem relatively simple opportunities, kind of low data amounts, probably not that commercially attractive. So what's really driving them to offer low power connections at such a low cost?
It's a really good question, really. Of course, you know, the connectivity really is important, and I think really where we will see really a lot of the majority of revenues in the space come from is really the management of these connections. So the service on top of the actual connectivity is really important, rather than the revenues providing the cellular connection itself. Off the top of my head, I think it's something like 7 to 10% or less than 10% really of revenues. So operators do have a part, but any way that they can move forward to really partner either in verticals or other IoT ecosystem players to really move towards servicing is really where the value is really. And yeah, that's what I think.
Very good. I've had I put another question in. Who do you see as deploying the networks for non-licensed LPWA?
Ooh, who do I see as deploying the networks for non-LPWA? Well, I think the LoRa Alliance is making quite steady headway as well. Though that's not to undermine Sigfox. It's quite hard for me to say at the moment, Andrew. Would you mind if I came back on that particular question offline?
Yeah, I mean, certainly we can answer the question in the write-up of the webinar.
Sure.
Yeah. Now, looking at eSIMs, how do you see the eSIM standard evolving over the next few years?
Right. Well, this is a really interesting question. So I'm glad it's actually come up. So obviously, with eSIMs, I mean, obviously there's huge potential, there's huge advantages there, and the GSMA has played a very key part in standardizing that and pushing it out, as mentioned earlier as well. So I think that, you know, the advantages, as I've said, is that it can be soldered down. There's remote SIM provisioning, over-the-air updates, and changing of operator profiles. At the moment, there is a lot of talk in the industry among operators and vendors, OEMs really together, talking really about what is the next step of, you know, after eSIM. You know, we've deployed it, we're scaling it. What is next? And there's a lot of talk about moving towards iSIM as the next form factor. So what really iSIM is, the eSIM, is it's another kind of step that still builds on the same architecture that eSIM is built upon. But again, it's just reducing form factor and space and cost again. So it optimizes, for example, the size and the surface area uptake on printed circuit boards. It reduces the cost of build of materials compared to eSIM, and it decreases power consumption compared to eSIM. So I think what its main basically value is really building a secure system on chip with iSIM. So that really drastically reduced costs, really. And so basically, to sum up again, it's moving SIM functionality from a separate chip into a secure enclave on a main system on chip. So, you know, what's the big deal there? Well, there's new opportunities really to connect further things, even objects, because the form factor and the cost is really reduced. It's just there's other areas, I think, to kind of address here, really. And that includes like understanding like how the security of that is established. Is it using techniques? Is it as robust? Is it as detecting as the eSIM standard is? Really, security is one of the key areas there that is kind of coming to the forefront of people's minds as we're moving eSIM to iSIM, really.
Very good. And in terms of sectors, well, you pointed towards a few sectors today that you expect to adopt LPWA technologies. Mm-hmm. the most primed for disruption from LPWA?
Sorry, Andrew, could you say that again? Which
sectors do you think are the most primed for the disruption from LPWA, IoT technologies?
So we're saying the disruption of LPWA, disruption of these different sectors to LPWA. So not talking about sectors that have strong potential for LPWA to flourish in.
No, when there's disruption likely to happen.
Right, yes. Well, I mean, you know, as explored, I mean, we highlighted very strong use cases for both smart metering and smart cities as well as that agriculture. I guess the question is really around the business model. So we were exploring for agriculture that although many developing or emerging markets can see benefits of using LPWA, the ability to raise the funds and the budget to really spend on that will be quite challenging. This, you know, the challenges that they're going through with theft of devices and so forth, really, and tampering, really. But we do see that the smart metering segment accounting for the large number of cellular LPWA connections throughout the forecast period, really. Again, you know, driven by energy service providers that are motivated by smart metering initiatives and governments as well that are pushing the need for standardization as well. POS was very strong as well, with a good opportunity there as well, because there's a very prime opportunity for LPWA to address the issue of indoor coverage that some of these kind of companies that are using kind of POS terminals have experienced really in the past. So ensuring that deep indoor coverage of those vital devices is very key as well, and also for them to be able to leverage power sources that can mitigate that issues as well.
Right. Do you see any challenges to adoption of LPWA? We presented some big growth figures today, but are there any difficulties to achieving those sorts of figures that we might not have thought about?
Yeah, sure. I mean, as mentioned earlier, I think security is one of those most important challenges, really. I mean, you have unauthorized attacks and breaches that can happen at several levels. So there is a need for all players in this space, you know, OEMs, really to collaborate on securing that, really, because if you imagine all these millions of connected devices in smart cities and smart meters being tampered with, you know, that is really for security to really be enforced. And I think there is work being done by GSMA and ETSI, particularly on the SIM kind of standard as well, really. So, you know, if you think about all those different kind of, you know, amount of data and types of data being transferred over the networks, it's really key to enforce that and have that standard, you know, really standardized or certified. As well as another challenge was, I think I was exploring for smart cities, really, is really understanding each city obviously is different to each other, and understanding the key constraints of those cities will help to incorporate LPWA business models much more you know, effectively, really. The financing, again, of those projects, you know, by authorities, by the private sector is really important, but also educating, I think, those stakeholders on the different LPWA technologies, really, and what is to really use in that case as well. So it does depend, I think, on a range of different factors. We said security as well for smart cities, you know, budget, the scale of the actual project, and educating stakeholders on the actual project as well. So those really are the main kind of challenges, I would say.
Thank you. I've just got one question, which is really a point of clarification. It's on one of your slides. So when you're talking about eSIM statistics, eSIM forecasts, does it also include new SIM, or is it only eSIM?
It's only eSIM that's included in there, not new SIMs.
Right, thank you for that. And the final question for today is LPWA suitable for global opportunities, sort of people, organizations with multinational operations?
Well, that is a tricky question. I would say it does depend on, I think, on the sector, and also the type of LPWA technology that you would go with, really, because, for example, you have unlicensed players like the LoRa Line who would have agreements between different markets, you know, for cases such as tracking, for example, where you can transfer from one market to another market and have a handover. So again, it depends on the scale of the operation, the market which it's in, and the type of LPWA technology that you're going for.
Thank you very much, Elson. We put you on the spot there with all those questions.
That's all right.
On that note, I'd like to thank you very much for your excellent contribution today. I'd like to thank Juniper for sharing research, and I'd like to thank the people that have been listening in to us today. As I said, we will do a write-up of the webinar, which we'll be publishing before too long, and the video feed will also be on the MEF website. So thank you all, and I look forward to having another one of these interesting talks within the not too distant future. So, good afternoon and goodbye.
Take care. Thank you. Bye.